Hi, hello and welcome to this discussion on next of the miscellaneous topics. So here we'll discuss content providers. Last time we talked about permissions. Today we'll talk about content providers and then app settings as well. So content providers is one of the four core components of Android, like activities, services, and broadcast receivers. What that means is content providers will have to be specified in the manifest file. And they are like the building blocks and they have been part of the design from the get-go. Okay, so let's see. So content providers and why were they designed in the first place? So content providers were designed to help applications manage access to their data. We know that all Android applications, they work in their own sandbox. And what that means is another application cannot access the data that is private to this particular app. Now, there are ways of passing some data to other apps. You can, I'm pretty sure you can quickly think of some of those. We have dealt with intents, for example, to pass messages, but intents can only carry the simple serializable data that can be put on bundles, right? What if you want to deal with more complex data? For example, um, data that is in a file. Let's consider this example. So you have an app that launches the camera app. So let's say you are building, a messenger or a social media app, and you want to take a picture and then share it on your social media app or through the messenger app. So you launch the camera application using an implicit intent. You go there, take a picture, but how do you get the picture back? That picture is going to be that selfie or whatever, even a video you shoot, all of that is going to be stored in the local or private file store of the camera app. And that is the right way to go for that app, right? You don't want that app to have the photos available to entire rest of the world. That will be a major breach of privacy. And just imagine any malicious app can be installed on your phone and it can access your photos and other private data associated with that, right? So that's a good use case or a motivating example for content providers. So uh, such data, such file, for example, that entire file can be shared by the camera app with your social media app. And that is, in fact, the most recommended way of dealing with such situations. So, what do content providers do? Content providers basically encapsulate the data and provide a mechanism for defining that data security. So, we'll see how you can specify permissions when you design a content provider and how the users of that app um, should use those should ask for using those permissions when they want to use it. Um, so we'll see that the architecture that we have seen in discussion for the databases and all, which is somewhat similar to what you see in content providers. But there are some differences and some specific recommendations when you should use what. So we'll get there soon. All right. So here is a you know the broad picture of how the content providers should be made available and used. Basically, it's a content provider is an interface, and I mean it's a Java interface as well as the interface to connect data from one process to another. Content providers work with inter-process communication clearly, and they can also deal with threading, background threads. So, as it shows here in this picture, you can provide I mean, you can implement a content provider that will access your data storage, and then with appropriate permissions and such, other applications can access it by writing a client. So a client of a content provider can access the um, data of your application, the one that is in this dotted rectangle, through this content provider. Um, so um, Typically, you would work with content providers in one of the two scenarios. You may want to implement the code to access an existing content provider. That is when you are here, you're writing the client for that. Or you may want to create a new content provider here, um, to expose the data of your own app that is again in the dotted rectangle with some other apps. Okay. So first we'll take a look at writing a client. By the way, and this what I just said perhaps um, makes clear an important point about content providers. You would not write content providers to access data in your own app. I think that's a straight away given, but you have much better many different ways of accessing your own data in your app. Um, and basically, content providers is an overkill and totally unnecessary for that. So it's only for communicating with other components. So let's first look at the client side. If there is a content provider already out there, how you can access it. So, oh, I clicked, double click there, sorry. Content providers present data to other apps, as we have seen, and the data that is provided is similar to the relational database tables. So you'll get columns, you'll get rows. Each row will be an entry in that table, and then you can choose which columns you want to look at. So here is the sort of the hierarchy of entities that deal with it. So you have a data storage and a content provider of another app. You would write in your own activity or fragment, you would write the client code that accesses the content provider data through a cursor loader. Cursor loader is responsible for asynchronous queries in the background. It can handle asynchronous queries in the background. And then content resolver, it communicates with that instance of content provider and gets the data for you. Content provider in turn uh, operates on these queries, gets the data from the storage, and returns the data to the content resolver, which is then put into a loader, which deals with these asynchronous queries and so on. And then it's shown here on the fragment. Um, so content resolver is capable of providing basic CRUD functions: create, retrieve, update, and delete. And those can be passed down to the data through the provider. And that's how it essentially works. So having the asynchronous query through cursor loader lets your UI continue to work without getting stuck for fetching the data. So that's the same principle that we have seen with databases and with the work manager in the previous few lectures. So here is an example of creating a dictionary. So a dictionary of words, there is a default dictionary, and then there can be words that the user adds. So here user will be different apps. So let's say the word MapReduce was added by user one. It has appeared 100 times, and the app that added it had its locale set to US English, whereas precompiler was added by another app. It appeared like 200 times, and it had French for the local, and so on. Okay, so all these words you can see are programming related word. By the way, this example is from the official guide. So yeah, so all these programming or computer science related words are not part of standard dictionary, and then they are added by the user. Okay, so the dictionary is stored as a file or a database, you would imagine, and so dictionary is an app, right? You may have your any of the dictionary apps, inbuilt or third party, and then they also let you add new words. So the spell checker doesn't flag them um, when you're writing some text. Okay, so that is a data that can be made available to other apps. Um, so, say your Messenger app or your email app, should not flag these words as misspelled words. So, for example, it should not try and change applet to apple, the fruit. If you are communicating about some technical stuff in an email, let's say. Okay, so for such purposes, you'll have to pass on this data from which is private to the dictionary app to your email app. Okay, so in this table, so the column headers, they become the columns of for the data stored in the provider, and then the ID is the primary key here. So using underscore ID is a good way of using the standard way of using the primary key. Okay, um, so how do you access this, or what kind of query can you create? So we'll see a generic example first, then a more specific example later. Okay, so this is how you can query the user dictionary and then get the result. So a cursor um, is returned when you call get content resolver and then query, and then you can pass it user dictionary words content URI, which is the content URI of the word table. We'll see how to create this or how to get this. Projection is the second parameter, which is the columns to be returned for each row. Um, and this is an array, and you can choose to only have the word and the locale, for example. You this one doesn't have meaning or any other data, of course. You probably won't even need the frequency um, to check if the word is in the dictionary or not, right? So you can choose only the specific columns from the table using projection. Selection clause gives you selection criteria and selection arguments, kind of add on to that selection criteria. We'll see in a second an example. And then sort order is whether you want to sort the rows that are returned or not. Okay, so these map to an SQL-like query, as you can imagine. So URI basically translates to from the table name. URI gives you the table path and name. Projection, as I said, gives you columns. Selection gives you where column equals value, and selection arguments. This is somewhat of a non-standard from SQL, but it lets you replace a specific columns value. I mean, question mark with a specific value. Okay, so sort order then, as we saw, can let you sort it. Okay. So how is the content URI created? So the content resolver parses the URI's different fields called authority and path, and that's how the system knows where to look for it. Um, Content resolver can basically dispatch the query arguments to the appropriate provider based on this. And the content provider uses the path part of the URI to choose the table. So that's how they work with each other. Okay. Um, all right. So a URI has the authority and path. Here is an example. We see the authority user dictionary and the path is word. So path is basically the name of the column. And then you always have what's called a scheme. It tells you what type of URI it is. Okay? So to get an individual row from the table that we have seen, you can write a code like this. So single URI will be content URIs, then with appended ID, user dictionary word content URI, which is the one we have created here, and then ID 4. So it will fetch you the fourth one from it. So URI and URI builder classes, we have seen URI example with the implicit intent with browsers before. Okay. They provide methods for constructing URIs with from strings and using IDs with them is easy, very convenient, straightforward with the content URIs class methods. So use of that ID field can be very straightforward. Okay, now how do you retrieve data? First of all, you need to have permission. So requesting a data, or rather retrieving the data requires you to request a specific read access permission for the provider. So here is an example for that. So read user dictionary. This permission is defined in the dictionary app, should be defined in the dictionary app. And you should specify user's permission, blah, 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 in your manifest file if you want to use it. And when the user installs that application, the user is basically implicitly granting this request. We talked about permissions last time. Refer back to that if required. You would find the exact name of the permission in the documentation. These strings, they work as the unique IDs, and you have to match that exact string. So yeah, here is the example. So the second step after requesting the permission, which will be granted implicitly, is to construct the query. So let's go and take a look at that. Okay, so this is one way of building the query, where you see a string array called mProjection, and we are choosing the word ID, the word itself, and the locale as the three columns. We're not trying to get all the rows, not required, not relevant in this particular use case, let's say. Okay. So yeah, these are the three columns that will be returned. And the selection clause here is null because we don't want to put any other selection criteria like where where word is something or anything like that. But if we wanted to provide something there, then you could provide a value for selection args. Okay. So selection clause is a combination of logical and Boolean expressions. It can have column names and values, etc. And the parameters for that can be specified using the array selection args. Now, for a more concrete example. So here we are trying to build an SQL-like query that will access the word which is given by the user input. Okay. So selection args is empty to begin with, and then search string is what you get from the user input. Search word dot get text dot toString. So let's say you're trying to get a bird and you want to search it in the dictionary. Okay. Then it checks if the search string is empty. If it is, then you want to look at all the words in this case. So you set clause to null. If it is null, it will return all the words. And you set the first argument to an empty string. But if you have an actual value, then you the append it. Then you put equals question mark, like you might have seen in several URI queries online. When you do Google search, for example, you append it with equals question mark and then add the search string on top of it. So that's where the text goes into selection args. Okay, so here is how you would use selection args. Now, how do you access it? Okay, so let's look at a more concrete code of getting the cursor. Get content resolver dot query. You have the URI, you have the projection, clause, args, and order. So this call is of course standard, but you put values in the projection, clause, args, etc. Okay, so if the cursor is null, which could be because of some internal error, you would handle that case. If it is not, then you check if the cursor get count is less than 1. That is, if it returned an empty query. In that case, you should inform the user that no matches were found. And then if it's not less than 1, you have at least one result in the query, then you go ahead and basically handle that result. Okay. Yeah. What is a cursor? Cursor is a way of mechanism for handling random read-write access to the rows. So it you can jump to the next one. You can iterate over all of those and so on. And it can work with an adapter and put everything, all the results on a list as well. So we basically created a SQL like query which would match this select ID, word, and locale, those three things coming from the previous slide. And then from the table words, where word equals the user input, the search string, and then ordered ascending. We don't have the code for that, but I mean, not shown here, but you can simply put that in the sort order. Okay. All right, let's pause here and we'll come back with displaying the results and other things in the next video.